Okay, let's try to solve your activity last meeting. This is about the lateral earth pressure. So for problem number 1, we have here the figure shows a cohesionless soil. So yung cohesionless soil, that is C, is equal to 0 with an excavation of 5.2 meter deep supported by sheet, sheet pile wall. So meron tayong 5.2 dito na excavation. The pile extends to a depth of 3.4, kaya may 3.4 tayo dito, below the bottom of the excavation. The angle of internal friction of the soil is 33 degrees and its density is equal to 18 kilonewton per cubic meter. The water table may be assumed to be below the bottom of the pile. So yung water table natin, andito siya. Okay? Andito yung water table natin. So first, we have to determine the active thrust on the wall per horizontal meter. We have to neglect the friction. Second, we have to determine the required allowable passive resistance force per meter that must be mobilized for the stability of soil. So ano daw yung equivalent passive resistance para hindi gumalaw yung ating sheet pile, yung ating wall. So, and for letter C, we have to determine the theoretical or the actual passive resistance available per meter. Okay. So, ito yung ating figure. So, ito yung na-excavate tayo. Nag-excavate tayo, kaya meron tayong na-excavate dito. And then, sabi dito, yung pile daw natin nag-extend ng 3.4. So, yan yung extension na 3.4. So, yung total length ng ating sheet pile dito, that is equal to 8.6. So, yung total length ng sheet pile natin is equal to 8.6 meter. So, eto, below 5.2, meron tayong soil dito, di ba? Kasi hanggang dito lang yung na-excavate natin. So, mag-e-extend siya. So, under the ground na ito. So, meron tayong soil dito. And then, ito yung soil naman natin dito sa ground. Yan. So, ito yung in-excavate natin. Yan yung in-excavate natin. Okay. So, yung una, i-determine daw natin yung active thrust on the wall per horizontal meter. So, per meter. So, to solve for the active thrust, we must solve first yung ating coefficient of Rankines earth pressure, yung Ka, and then yung Kp sa active and then sa passive. Okay? So for the value of our Ka, that is equal to, if you still remember our equation, that is equal to 1 minus sine angle of internal friction plus 1 sine of angles. Yan yung magiging value ng Ka natin. And yung Kp natin, that is 1 plus sine 1 minus sine of the angle. So, meron tayong angle which is equal to 33 degrees. So, you just have to substitute 33 degrees here. Ang magiging sagot natin dito for our active, that is equal to, yung coefficient of Rankine active earth pressure natin is equal to 0.29, and then yung passive naman, that is equal to 3.39. So, kailangan kasi natin ito to solve for the active thrust on the wall. Okay? So, next, we have to draw our pressure distribution diagram. So, ito. So, yung soil natin, meron siyang 18. So, yung active force natin, andito yung water table natin at the bottom. So, ganyan yung magiging distribution natin kasi wala tayong water table dito. So, ito yung active natin, ito yung magiging passive natin. Itong triangle na ito, this is due to the soil here. Diba? Meron tayong soil dito. And then, yung next distribution natin is due to this soil dito, just below our excavation. So, meron din tayong pressure diagram na triangle yan. Yan. So, etong triangle na ito, this is due to the pressure ng soil dito. And then, etong triangle, this is due to the pressure of soil here. Okay? So, let's say this is P1 or PA. So, that is our active, and say this is PP. Okay? So, solve muna natin yung ating pressure dito bago natin kunin yung active or yung active pressure cross natin. So, for letter A, ang hinahanap natin is determine the active thrust. So, for letter A, so we need to solve our pressure at 8.6 kasi etong soil na ito, soil lahat yan. That is 8.6 in length. So, at 8.6, kasi dito wala tayong surcharge, kaya 0 ito. Okay? So, at 8.6, that is equal to Ka, our unit weight, and our height. So, meron tayong density that is equal to 18 kilonewton per cubic meter, and meron tayong height which is equal to 8.6. So, solving for our value here, we have 0.29 multiplied by 18, that is in kilonewton meter cube, multiplied by the height, which is 8.6 meter. So, yung pressure natin at 8.6 is equal to 44.89. So, we have 44.89 kilonewton per meter square. Okay. So, ano na ngayon yung magiging active thrust natin? So, ang active thrust natin, ito, yung force na PA natin dito sa ating pressure diagram. Yan yung sagot natin dito sa letter A. So, nasolve na natin ito, yung pressure natin at 8.6, makukuha natin yung PA. Tingin lang kayo dito sa triangle. So, para sa PA, that is equal to 1/2 of the pressure at 8.6 multiplied by the height. That is also equal to 8.6. So, substituting our values here, we have 1/2. That is 44.89. And yung height natin, that is 8.6. So, yung magiging PA natin dito is equal to 193.04 kilonewton, that is per meter of our wall. So, ito yung magiging active thrust natin per meter of our wall. That is 193.04 kilonewton. So, this will be now our answer here at letter A. Yan, that is 193.04. Okay? So, for letter B, sabi natin, we have to determine the allowable passive resistance force per meter that must be mobilized for the stability of the wall. So, dapat walang overturning dito sa wall natin. Dapat stable lang siya. So, anong gagawin natin to solve for our required allowable passive resistance? So, ang hinahanap natin dito is etong PP. Pero hindi lang yung PP yung hinahanap natin dito. Kasi pag PP yung hinahanap natin, that is for letter C. Yung theoretical and the active passive resistance available per meter. Okay? So, for letter B, dapat ito yung allowable daw na value ng PP para hindi mag-move yung ating wall, para stable lang yung wall natin. So, anong gagawin natin dito? We have to take our moment dito sa ating base. Diba? Pag nag-moment yung PA, yung active natin, active force, and then that is equal to the moment of PP dito sa ating base. Equal siya. So, kailangan nating yung moment ng passive and active is equal to, is the same para mag-equal ka. tayo sa 0 para stable lang ito, hindi mag-move yung ating wall. Okay? So for letter B, for the passive resistance that must be mobilized for stability of wall, magmo-moment tayo dito sa ating base. So moment at base is equal to 0. So yung PA natin, nag-moment tayo dito, say this is positive, yung clockwise. So that is PP times etong length natin dito, that is 1/3 of 3.4, and then yung ito naman, that is 1/3 of 8.6. So that is PP times 1/3 of 3.4 positive clockwise, counterclockwise, so minus PA multiplied by 1/3 of 8.6, that is equal to 0. So stable siya kasi equal dapat yung moment natin sa 0. Okay? So yung value natin ng PA, given, na-solve na natin for letter A, that is equal to 193.04. And yung hinahanap natin sa letter B, itong PP natin dito. Ito yung hinahanap natin for letter B, yung PP natin dyan. Okay? So, substituting yung values natin dito, that is equal to PP times 1/3 of 3.4 minus 193.04 times 1/3 of 8.6, that is equal to 0. So, ang value natin ngayon for our passive resistance is equal to 488.28 kilonewton, that is in per meter of our wall. Okay? So, ito na yung magiging sagot natin for letter B. So, kindly check my calculation. So, for letter B, okay, check na natin yung letter B. Ito yung allowed na passive resistance para yung wall natin is stable. Okay? So, that's for letter B. And for letter C, we have to determine the theoretical or the actual passive resistance available per meter. So, ang hinahanap natin dito is yung value ng ating actual passive resistance. So, our pressure here at 3.4. Solve muna natin yung pressure natin dito. Then, you just have to get the area. Yan yung force natin dyan. So, pressure at 3.4 is equal to, that is KP, unit weight ng soil, tapos yung height. So, yung KP natin is 3.39, yung unit weight natin is 18, and yung height natin is 3.4. So, this is equal to, that is 3.39 multiplied by 18 multiplied by 3.4. So, this is equal to 207.47 kilonewton per meter squared. So, ano na ngayon yung magiging PP natin? So, PP is equal to 1/2 the pressure at 3.4 multiplied by the height. So, that is equal to 1/2 207.47 multiplied by the height, which is equal to 3.4. So, ang value natin dito is equal to 352.7 kilonewton per meter of length ng ating wall. So, this will be now our answer in letter C. Okay? So, for problem number 1, letter A, ito yung sagot natin, letter B, and letter C. Okay? So, let's move on doon sa ating second problem natin. This is actually the same in our example. Di ba may example tayo na ganito? So, the figure shows a retaining wall. So, we have to determine the total active force acting on the wall. We also have to determine its overturning moment and yung ating, if a surcharge, so for letter C, pag may surcharge daw tayo na 18 kPa, ano yung magiging total active force natin. Okay? So, para mas madali, i-drawing natin yung ating pressure distribution diagram. Okay? So, first is to solve for our coefficient of Rankines active earth pressure, yung KE natin. So, yung KE natin, KE1, yan yung ating coefficient just above our groundwater table. That is equal to 1 minus sine of 30 over 1 plus sine of 30. So, this is equal to 0.333. And then, yung ating KE2, this is just below our groundwater. That is equal to 1 minus sine of 28 over 1 plus sine of 28. So, that is equal to 0.36. Okay? So, sa pressure diagram natin, solve natin yung ating mga pressure. So, at 0 meter, our pressure is equal to 0. So, 0 tayo dito, okay? At above muna tayo, above our groundwater at 2.2. Just above our groundwater, ang ating pressure at 2.2 just above, that is equal to K multiplied by our unit weight multiplied by the height. Yung K natin is equal to 0.333. That is just above. Multiplied our unit weight, 17, and our height, that is equal to 2.2. So, yung value natin dito is equal to 12.45 kilonewton per meter squared. So, kindly check if this is correct. So, dito meron tayong value that is equal to 12.45. So, ganyan. Okay? Just below naman our groundwater at 2.2 pa rin tayo. Ano yung magiging pressure natin at 2.2 just below? So, yung KA2 naman yung gagamitin natin. Unit weight and height is still the same. So, ito lang yung papalitan natin. That is equal to 0.36 multiplied by 17 multiplied by 2.2. Ang value natin dito is equal to 13.464. That is in kilonewton per meter squared. So, meron tayong value dito na equal to, say that is equal to 13.464. Okay? And then, at yung height natin, that is 2.2 plus 3.8, that is 6 meter. At 6 meter, yung magiging pressure natin at 6 meter is equal to ito, di ba? That is 13.464 plus yung pressure natin dito. Okay? So, that is 13.464 plus, ano yung pressure natin dito? So, that is 3.8 in height. Tapos, saturated unit weight given, 18.4. So, ima-minus natin yung unit weight ng water dito. Kasi, saturated yung unit weight na given. Kasi, meron tayong groundwater. So, that is plus, yung K natin is K2. That is 0.36. 18.4 minus our unit weight of water multiplied by our height, which is equal to 3.8. So, ano yung magiging value natin dito? That is equal to 25.22 kilonewton meter squared. So, kindly just check my calculation if it is correct. So, meron tayong pressure dito at the bottom, which is equal to 25.22. So, ganyan yung magiging pressure diagram natin. That is due to our soil. Okay? So, meron tayong groundwater. So, kunin natin yung pressure ng ating water. That is the unit weight of water times height of water. So, this is equal to 9.81 multiplied by 3.8 that is equal to 37.28 kPa. So, magkakaroon tayo ng water which is equal to 37.28. So, this is the pressure due to the water. This is due to the soil. This is due to the water. Okay? So, for letter A, we can now solve for our total active force kasi meron na tayong values ng pressure. Diba? So, if we try, so ito yung unang P1 natin. This is P1, itong triangle na ito. Ito yung P2 natin, yung rectangle na ito. And then, ito yung P3 natin, yung triangle dito, and ito yung magiging P nung water natin. So, to solve for the total active force, just have to add this P1 plus P2 plus P3 plus PW. So, we need to solve first the values of P1, P2, P3, and PW. Okay? So, to solve the values, so let's go to the P1. So, P1, that is equal to, that is a triangle, so 1/2. 1/2 yung value natin ng pressure, which is 12.45, multiplied by the height, which is 2.2. So, that is equal to 13.695 in kilonewton per meter of length. And then, ano yung magiging P2 natin? So, ito yung P2 natin, itong rectangle. So, that is 13.464 multiplied by the height, which is 3.8. So, ang value natin dito is equal to 51.16 kilonewton per meter of length ng wall. So, ano yung magiging P3 natin? So, itong triangle na ito. So, yung value natin dito, that is equal to 25.22 minus 13.464. 464, diba? So, this is 1/2. So, 25.22 minus 13.464 multiplied by the height, which is 3.8. Ang value natin dito is equal to 22.34 meter. Okay? Kilonewton per meter. And then for our pressure due to our water, this is triangle, so that is 1/2. Yung pressure natin, 37.28 multiplied by the height, which is 3.8. So, ang value natin dito is equal to 70.83 kilonewton per meter. So, yan yung magiging values natin for our P, yung forces natin. So, for letter A, ano ngayon daw yung magiging total active force? So, we have the total active force. Say that is equal to, tawag nito, summation ng ating forces, which is equal to P1 plus P2 plus P3 plus PW. So, yung total active force natin is equal to 157.93 kilonewton per meter length of our wall. So, ito na yung magiging answer natin for letter A. So, yan yung magiging total active force natin on the wall. Okay, so for letter B, we have to determine its overturning moment. So, ano daw yung magiging overturning moment natin? And to solve the overturning moment, we have to take the moment ng forces natin dito sa ating base, diba? Para ma-solve natin yung ating overturning moment. Kasi, pag nag-moment tayo dito sa base, yan yung magiging moment para mag-overturn yung ating wall, diba? So, isolve natin, mag-moment tayo dito sa base para makuha natin yung overturning moment. Okay? So, P1. So, for the letter B, ito na lang sa taas. So, for letter B, for the overturning moment. Okay? So, yung P1 natin, pag nag-moment tayo dyan, kunin natin yung distance dyan. Yung P2, kunin din natin yung distance. And then yung P3, yung distance dito. And then yung PW, yung distance dyan. Okay? So, for the overturning moment, unahin natin yung P1. So, P1 is equal to 13.695. So, 13.695 multiplied by the length, that is 3.8 mula dito, tapos plus nung 1/3 nung 2.2. So, 3.8 plus 2.2 over 3, that is 1/3. Okay? Plus, yung P2 natin, that is equal to 51.16 multiplied by the distance doon sa centroid natin, that is 3.8 over 2, di ba? Okay. Plus yung P3 natin, which is equal to 22.34 multiplied by the centroid of this P3 mula dito sa base natin, that is 3.8, the 1/3 of 3.8, so 3.8 over 3. And lastly, yung water natin, which is plus 70.83, yung distance natin dito, that is equal to 3.8 over 3. So, just have to calculate, and yung magiging overturning moment natin dito is equal to 277.304. That is in kilonewton meter per meter length of wall. So, ito yung magiging overturning moment natin per meter length of wall. So, this will be now our answer for letter B. Okay? And then for letter C, if a surcharge of 18 kPa is applied on the top of the backfill, so magkakaroon na tayo ng surcharge dito. So for letter C, mag-a-add daw tayo ng surcharge. So if you still remember, yung surcharge natin is equal to the coefficient multiplied by the surcharge, diba? So yung surcharge natin dito, that is equal to 0.33 multiplied by the surcharge, which is 18. So 0.33 times 18, that is equal to 5.994. So hanggang dito. And then yung surcharge natin, if our KE2 is 0.36, that is 0.36 multiplied by 18. Diba? Ito yan. Yung K multiplied by our surcharge. So 0.36 times the surcharge 18, that is equal to 6.48. So 6.48 din dito. So yan yung magiging addition na surcharge. So pag kinuha natin yung forces dito, so say this is P4 and this is P5. Okay? So, solve natin yung value ng P4 and P5 muna bago natin isolve yung total active force pag nag-add daw tayo ng surcharge. So, solving for the P4, yung surcharge natin, that is equal to 5.994. That is rectangle, so length times width times yung height natin, that is equal to 2.2. So, ang value natin dito is 13.19 kilonewton per meter. Okay? And then yung P5 natin, that is equal to 6.48 multiplied by the height 3.8, that is equal to 24.624 kilonewton per meter length of our wall. Okay? So we can now solve for our letter C, yung total active force. Pag yung total active force with surcharge. So you just have to add the value of P4 and P5. So yung total active force natin, that is equal to P1 plus P2 plus P3 plus P4 plus P5 plus yung ating water. Okay? So nasolve natin actually ito, P1, P2, P3, and PW. That is equal to, yung value natin dyan is equal to this, 157.93. So we have 157.93. So you just have to add yung P4 natin, which is 13.19. And then yung P5 natin, which is 24.624. So yung magiging total active force natin, if we have a surcharge of 18 kPa, is equal to 195.7 kilonewton per meter length nung ating wall. So this will be now our answer for letter C for problem number 2. Okay? Let's move on to our problem number 3. So we have a 6-meter retaining wall is supporting a soil with the following properties. So meron tayong following properties dito. So assume daw natin na no tensile crack occurs in the soil, didetermine natin yung normal pressure acting on the back of the wall. And for letter B, pag may tensile crack daw tayo, ano daw yung magiging active pressure natin sa wall? And then for letter C, we have to locate the location ng ating tensile crack. Okay? So, say we have here our wall that is equal to, ito yung wall natin, that is equal to 6 meter. Okay? So, for our pressure diagram, okay. So, to solve for our pressure diagram, we have to find first yung ating coefficient. Given yung unit weight, given yung angle of internal friction, and meron tayong cohesion. So, meron tayong pressure diagram due to this cohesion. Okay? So, yung ating due to soil. So, isolve muna natin yung coefficient natin, yung Ka, that is 1 minus sine of angle of internal friction, that is 25 degrees over 1 plus sine of 25 degrees. So, yung active natin is equal to 0.406. So, kindly check na lang yung calculation ko. Okay. So, at 0, yung pressure natin due to our soil is also 0. 0. At 6 meter, yung soil muna ito, due to our soil. Yung pressure natin at 6 meter is equal to Ke unit weight and then yung height. So, yung value natin dito, that is equal to Ke, that is 406. Yung unit weight natin, that is 16 kilonewton per cubic meter. And then yung height natin, that is equal to 6. So, solving, yung magiging value natin dito is equal to 38.976. So, ito yung magiging pressure natin at 6 meters. So, meron tayong pressure dito which is equal to 38.976. Okay? So, say yung force natin dito is equal to P1. That is for the soil. And then, meron din tayo ditong cohesion. Yung cohesion natin is not equal to 0. So, pag may cohesion, that will cause our soil to have a crack. Parang mag-crack yung tensile natin. Magkaroon ng tensile crack yung ating wall. So, due to the cohesion, ano yung value ng cohesion natin? That is equal to, if you still remember yung cohesion natin, yan yung ating formula, di ba? Positive, sorry. Yan, positive pala. Positive. Then if you still remember yung tawag nito, yung equation natin, yung pressure natin due to soil, ima-minus natin yung ito, due to the cohesion. So, magma-minus yan, di ba? Pero positive yan. So, if maalala nyo, yung equation natin, that is equal to the force, pressure, yung pressure natin minus the value or the pressure natin due to our cohesion. So, ima-minus natin siya. Okay? So, yung cohesion natin is on the right side kasi this will cause our wall to have a crack. And then, ano yung magiging value ngayon ng ating pressure due to the cohesion? Diba? Ano yung magiging value natin? So, due to cohesion, ang pressure natin is equal to 2C. So, that is 2C, the square root of Ka. So, ano yun? That is 2 times 14, the square root of 0.406. So, if you calculate that, yung magiging pressure natin is equal to 17.84 kilonewton per meter squared. So, may value tayo dito, that is 84. And say, yung ating force dito, due to our cohesion is P2. Okay? So, meron tayong P1 and P2. So, masosolve na natin yung problem for letter A. Kasi assuming no tensile crack occurs. So, wala pang tensile crack na nangyayari. So, ano yung magiging normal pressure acting on the back of the wall? Okay? So, for letter A, ano daw yung magiging normal natin? Normal pressure. That is equal to P1 minus P2. Diba? Wala pa tayong crack. So, ima-minus natin yung pressure due to our force, due to our soil, and due to our cohesion. So, yung magiging Fn natin dito, yung P1 natin, solve muna natin pala yung P1. So, ano ngayon yung magiging P1 natin? That is equal to 1/2 of 38.976 times 6. And then yung P2 natin, that is equal to 17.84 multiplied by 6. So, ano yung value natin dito? That is equal to, so this is equal to 116.93. And then, so paki-check na lang yung calculation ko. This is equal to 107.04. So, meron tayong value ng P1 which is equal to 116.93 minus yung P2 natin which is 107.04. So, ang magiging normal pressure natin acting at the back of our wall is equal to 116.93 minus 107.04. 9.89 kilonewton per meter length of the wall. So, ito yung magiging sagot natin for letter A. Okay? So, for letter B, meron na tayong tensile crack. Okay? So, ano yung magiging pressure diagram natin pag nagkaroon na tayo ng tensile crack? So, this is equal to 0 minus 17.84 magiging negative yan. So, andito yung ating pressure diagram. So, 18. And then we have 38.976 minus 17.84. That is equal to 21.14. So, positive. So, andito yung ating value which is equal to 21.40. So, ganyan yung magiging pressure diagram natin pag meron tayong tensile crack. So, andito yung tensile crack natin. Diba? Okay? So, ito. 0 plus negative. Kasi andito sa left side, negative kaya 17.84. 38.976 minus 17.84, that is 21.14. So, andito yung ating value. Okay? So, ito yung magiging tensile crack natin. If this is 6 meter, say this is y. Say this is y. And then the dimension, the distance here is equal to 6 minus y. So, ito, sabihin na natin, yung distance natin dito is y. And then, dito, since this is 6 meters, 6 minus y. Okay? And, say we have force dito. Let's say that is P3. And yung force naman dito, say that is P4. Okay. So, for letter B, ang hinahanap natin is the active pressure acting on the wall if we have tensile crack. Okay, so i-determine muna natin yung ating distance dito, yung y, para ma-solve natin yung forces. Okay? So, solving for our y here. So, tingnan natin itong triangle, that is 17.84 is to y. That is 17.84 is to y. Then, 21.14 is to 6 minus y. So, masosolve natin yung y natin dyan, di ba? So, we have 17.84 is to y. Similar triangle tayo, that is equal to 21.4 is to 21.14 is to 6 minus y. So, masosolve natin yung value ng y natin, which is equal to 2.746. Kindly check if my calculation is correct. And then, yung 6 minus y natin is equal to 3.254 meter. So, yan yung mga values ng dimension natin. Okay? So, for letter B, ang sabi natin for letter B, we have to solve for the active pressure acting on our wall. Okay? So, ano yung magiging active pressure daw natin pag may tensile crack? So, ang hinahanap natin for letter B is the value ng ating P4. So, yan yung magiging active pressure natin pag may crack. Di ba? So, pag may nag-crack, ito yung hinahanap natin na active. Hindi natin isasali ito. Kasi hindi na ito active. Okay? So, ang hinahanap natin for letter B is the value of our P4. Okay? So, for letter B, yung P4 na solve na natin yung dimension ng 6 minus y. Diba? Na-solve na natin ito. Meron na din tayong pressure, that is 21.4. So, masosolve na natin yung P4. So, the active force, if tensile crack occurs, is equal to the value of P4. That is equal to 1/2 yung ating pressure, which is 21.14 multiplied by the height, yung 6 minus 4, which is equal to this value, which is 3.254. So, ano yung magiging value natin for the active force? That is equal to 34.39 kilonewton per meter. So, this will be now our answer for letter B. And for letter C, ano yung magiging sagot natin? We have to find the location of the tensile crack measured from the surface of the horizontal backfill. So, na-solve na natin ito. So, ito yung distance natin mula sa ground surface. So, that is equal to y. So, for letter C, ang distance natin or yung location ng tensile crack natin, location of tensile crack from the top, from the surface, is equal to 2 ito na yun, kasi na-solve na natin, that is equal to 2.746 meters. So, this will be now our answer for letter C. Okay? For problem number 3. Okay, so that's for our problem number 3. So, let's move on for our problem 4. So, yung problem 4 natin. So, sabi natin dito, the backfill behind the concrete retaining wall. So, ito yung concrete retaining wall natin. Meron tayong backfill dito. Weights 100 PCF. This is pounds per cubic feet with an internal friction of 25. Meron daw tayong surcharge that is equal to 200. So, yung surcharge natin dito is 200 PSF. So, yung magiging unit weight ng stall natin is 100 PCF. Meron tayong surcharge na 200 PSF. So, for the problem, we have to calculate its total active force acting on the wall per unit width. And then, yung letter B, we have to determine its factor of safety against overturning. Okay? So, to solve our equation, first we need to find the value of our coefficient, that is equal to 1 minus sine of 25 over 1 plus sine of 25. Okay? So, that is equal to 0.406. Okay? So, pag meron na tayong Ka, we can now solve for the if this is our pressure diagram, masasolve natin yung pressure natin. Diba? Due to the soil, at 0, 0. Ihiwalay natin yung surcharge para mas madali yung pressure diagram natin. And then, at 17 feet, meron tayong pressure. So, at 17 feet, yung pressure natin is equal to Ka unit weight of height. So, yung value natin dito is equal to Ka 406 multiplied by the unit weight, which is 100 PCF, multiplied by 20 feet, yung height, that is equal to 812. This is in PSF. So, yung value natin dito is equal to 812. Okay? And then, due to our surcharge, ito yung pressure diagram natin due to the soil. And due to our surcharge, ano yung value natin? Due to surcharge, that is Q multiplied by the coefficient. So, ano yung surcharge natin? That is equal to Q multiplied by Ka. Yung Q natin is equal to 200 PSF multiplied by 0.406. So, ano yung value natin dito? That is equal to 81.2 PSF. So, meron tayong 81.2 PSF. Okay? So, masasolve na natin yung active force. You just have to add the forces due to our backfill, yung soil natin, say that is P1, and yung due to our surcharge, say that is P2. Okay? So, solve muna natin yung P1 and P2 natin. So, P1 is equal to 1/2 of 812 multiplied by the height, which is 17. This is equal to, wait. We forgot yung 3 natin dito. So, this is 20. So, hanggang dito dapat. So, hanggang sa bottom nung ating wall, yung ating retaining wall. So, nakalimutan natin yung 3 feet dito. So, that is at 20 feet. Okay. So, at 20 feet. At 20 feet. So, yung value natin dito is equal to 20 times 0, 0.406. That is equal to times the unit weight, which is 100. So, 812. Tama yung sagot natin, 812. 20 feet pala ito, nakalimutan natin yung 3 feet. So, times 20, ang value natin dito sa P1 is equal to 0.5 plus 812 times 20. This is equal to 8120 PSF. And for our P2, that is equal to 81.2 multiplied by 20. That is equal to 1624 PSF. Okay? So, for letter A, so for our letter A, yung total active force natin is equal to P1 plus P2. So, yung magiging value natin dito is equal to, ilan ito? 9744. This is in pounds per So, ito, mali tayo dito. Hindi PSF yan. That is, kasi ito, PSF na ito, multiplied by feet, magiging pounds per feet. Pounds per feet. So, yung magiging force natin is equal to 9744 pounds per feet of our length nung ating wall. So, ito yung magiging sagot natin for letter A. And for the letter B, we have to determine the factor of safety against overturning. So, if you still remember, yung ating factor of safety is equal to the righting moment over the overturning moment. Okay? So, isasali na natin itong weight ng ating concrete retaining wall. And then, yung unit weight ng concrete natin is equal to 150 pounds per cubic feet. So, PCF. So, yan yung unit ng concrete natin. So, para makuha yung factor of safety, isa-solve muna natin yung righting moment natin at saka yung ating overturning moment. So, ano yung forces na magkukos ng overturning? And then, ano yung forces na magkukos ng righting moment? Okay? So, kailangan muna din nating isolve yung ating weight ng ating concrete. Say, this is yung weight natin dito. Meron tayong W1, yung weight ng concrete dito. meron tayong hanggang dito, meron tayong W2, yung weight ng concrete natin dito, and then meron tayong W3, that is the weight of the soil. So, yan yung magiging factor nung ating writing moment. So, ano yung magiging overturning moment natin? Yung pressure, yung forces due to the pressure. Ano yung magiging writing moment natin? Yung factor due to the weight of our concrete and yung weight ng salt. Yan yung magiging writing moment natin. Yan yung magre-resist para hindi mag-overturn yung ating retaining wall due to the pressure, forces due to pressure. Okay? So, solve muna natin yung ating W1, W2, and W3. Okay? So, W1, W2, W3, and meron din tayong ito, say, yung W3 natin, weight nung soil dito. Ito. Okay? And then, yung weight due to our surcharge, say that is W4 kasi meron tayong surcharge. Pag wala tayong surcharge, wala itong W4. So, yung W3 hanggang dito. Yung soil dito sa likod ng ating retaining wall. Yung backfill natin. Okay? So, solving for our W1, W2, W3, and W4. So, start natin, W1. Ano yung weight 1 natin? Meron tayong unit weight of concrete that is 150. So, 150 multiplied by the area of this, that is 3 times 17. So, 3 times 17. So, ang magiging sagot natin dito is 650 pounds per unit length ng ating wall. So, per feet. So, pag minultiply nyo yan ng 1 feet, ang lalabas dyan, ay pounds lang siya. So, in per feet tayo dito. Okay? So, W2, that is equal to 150 times 16. Ito, yung length natin times 3. So, pag gusto nyo naka-pounds lang, multiply ninyo per unit feet or length ng ating wall. So, that is equal to 7,200 pounds per unit feet. And then, yung W3 natin, yung soil, ito yung soil natin, that is equal to 100 unit weight ng soil, that is equal to 100 multiplied by the area here, dito, backfill, just yung area dito, that is 17 multiplied by anong distance dito, that is 16 minus 5 minus 3. So, that is 16 minus 8. Meron tayong 8 dito. So, that is equal to 100 multiplied by 17 multiplied by 8. So, yung W3 natin is equal to 13,600 pounds per unit feet of the wall. And then, yung W4 natin, that is equal to 200. So, ito hanggang dito, that is 8 in dimension 8, that is equal to 1,600 pounds per unit feet. Okay? So, yan yung magiging factor natin dito sa ating writing moment. So, masosolve na natin yung writing moment natin at saka yung ating overturning moment. So, for the overturning moment, ang magiging factor natin dito is the forces due to pressure. So, pag nag-moment tayo sa base, makukuha natin yung overturning moment. Meron tayong P1 and P2, moment tayo sa bases. So, P1, that is equal to 8 to 120 multiplied by the distance, that is equal to 20 over 3. Plus that yung P2 natin, 1624. Yung length natin dito is 20/2. So, yung overturning moment natin is equal to 7373 PSF. Okay? And then, wait, moment tayo, hindi PSF. This is pounds per feet multiplied by the feet din ito. So, this is equal to pounds feet per unit length. So, per feet. So, per unit length of our wall. That is our overturning moment. Ano ngayon yung magiging writing moment natin? Okay? So, for the writing moment, so yung factor natin, itong W1, W2, W3, and W4. So, say mag-moment tayo dito sa ating toe. So, mag-moment tayo dito sa ating toe para makuha natin yung writing moment. So, yung factor natin, W1, 2, 3, and 4. So, start natin sa W1. So, 760. 7,650 pounds per feet multiplied by the length. Pag nag-moment ka dyan, that is 5. Tapos half ng 3.3 meter, that is 1.5. So, 6.5. Plus, DW2, 7,200. Yung length niya, half niya dito, yung centroid niya is 8. Plus, 13,600, that is W3. So, ano yung centroid dito? So, pag 8 yan, 4 to, di ba? So, 4 plus 3 plus 5, that is equal to 12. Plus, the 1,600, ito, parehas sila, yung centroid niya nasa 4 meter dito, plus 3 plus 5, kasi dito tayo mag-moment sa to, so that is 12. So, ang magiging writing moment natin ngayon is equal to 2, so paki-check na lang itong calculation ko, 725 pounds per feet per unit length nung ating wall. So, per unit length itong nakuha nating moment. So, ito na yung writing moment natin, ito na yung overturning moment. So, masosolve na natin yung ating factor of safety against overturning. So, that is equal to writing moment over overturning moment. So, writing moment, 289.725 over 7373. Ang magiging factor of safety natin ngayon is equal to 4.12. So, this will be now our answer for letter B of our problem number 4. Okay, so that's the solution for your activity. So, if you have any question, you can just ask in our group chat or you can just comment in our Google Classroom.